Hello everyone, we are still working in section 6.2, but today we're going to take a look at how to solve differential equations using a technique called separation of variables. So this is a favorite topic on the AP exam. It will be a non-calculator problem most of the time. So let's take a look at this first example. So what we're trying to do is we're trying to separate dx and dy and all the x's and all the y's. So how we're going to do that is to factor by grouping. So a lot of times we like to say separation of variables is SOV, separation of variables. So I'm going to rewrite y prime as dy over dx. We definitely need to see it this way. And then what I'm going to do is look at my first two terms and notice what they have in common, an x squared. So we're going to factor out an x squared. What will we have left? A 2y minus 1. And then my last two terms, I can factor out a 3, positive 3. And then what do I have left? A 2y minus 1. So that's a good sign that the 2y minus 1's match. We call those common binomial factors. So now dy over dx is going to equal, we'll factor out the 2y minus 1, and then we're left with x squared plus 3. So now we could separate the variables. So what I want to do is get all the y's to one side. So I'm going to divide both sides by 2y minus 1. So we'll say dy over 2y minus 1 is going to equal x squared plus 3 dx. So I have everything with a y on it on the left side, everything with an x in it on the right side. Now what are we going to do? We're going to integrate both sides. So right now, this was the process. We separated the variables, separation of variables right there. Next, we're going to integrate. So really what I want to show is the integral of 1 over 2y minus 1 dy is going to equal the integral of x squared plus 3 dx. Now we could use substitution. I'm going to try this without though. Because I have 1 over something, I know that's going to be the natural log of the absolute value of 2y minus 1. But if I were to take the derivative of this, I would still get a times 2 at the end, so we need to put a 1/2 out in front. Then technically it's plus a c1. We're going to get constants on both sides. And then over here we're going to have an x cubed over 3 plus 3x plus another constant. But then we could just bring all of our constants to one side. So now we have 1/2 times the natural log of the absolute value of 2y minus 1 is going to equal x cubed over 3 plus 3x. We'll call this a new constant c sub 3. That's just c2 minus c1 here. And then we could go ahead and multiply every value by 2. Multiply both sides by 2. So now we get the natural log of the absolute value of 2y minus 1 is going to equal 2x cubed over 3 plus 6x. And yes, this will change us to another constant. We'll just kind of call it the overall constant. And what we have here, because we're not completely solved for y yet, we call this an implicit solution. If this was all they were asking for, we would be done. But to continue, we want to solve for y in terms of x. So again, starting with the natural log of the absolute value of 2y minus 1 is going to equal 2x cubed over 3 plus 6x plus this constant c. What I'm going to do is rewrite the natural log, or we don't have to. We could just look at, we could take e as a base to both sides. So we're going to say e to the natural log of the absolute value of 2y minus 1. I was going to say we could also rewrite this as log base e. That's another way to look at it. And then we're going to have e to the 2x cubed over 3 plus 6x plus c. So what's going to happen over here is e to the natural log of this quantity is just going to leave us with the quantity, the absolute value of 2y minus 1, is going to equal e to the 2x cubed over 3 plus 6x. Now what I'm going to do with this is going to be helpful for our next step. I'm actually going to separate this, or kind of factor it using a law of exponents. So I could say it's e to this quantity times e to the c, because we would add our exponents if we wanted to go backwards here. And now e to the c, we could just call, that's just a constant, let's call that a. So now I get the absolute value of 2y minus 1, we'll put that a first, is equal to a times e to 2x cubed over 3 plus 6x. And hopefully this is looking a little familiar, a little more complicated, but if you guys recall, like the formula for compounding interest continuously, we get some value is equal to actually p times e to the RT. So this is sort of where that formula is coming from for right now. So now what we want to do, we have an absolute value equation. So yes, it's going to expand a little further here. So what this means, we go two directions from here, is that 2y minus 1 is going to equal a positive value here, a times e to the 2x cubed over 3 plus 6x, or 2y minus 1 is going to equal the opposite of this. And we do want to keep them separate. And then we just continue to solve for y. So I'm going to add 1 and then divide by 2. So y is going to equal positive a times e to the 2x cubed over 3 plus 6x plus 1 all over 2. Or y is going to equal the opposite of a times e to the 2x cubed over 3 plus 6x plus 1 all over 2. Now, if we had to do anything else from this, and we eventually will, we would just want to go back and use the positive value if they asked us to find a. We could use this too, but we have to remember when we substitute a in, we're going to get a negative value. So essentially, they both turn out to be the same. So if we needed to do anything more with it, always use the one where y is equal to the positive value. And we call both of these an explicit solution. We can actually see y in terms of x. All right, so let's try another example. Here again, we want to solve for y in terms of just x. This one isn't nearly as long. They're still pretty lengthy problems. It's just not as long as the previous one. So what we're going to do, we're going to start with, instead of y prime, we want to see dy over dx. And then kind of like what we did in the last problem, to separate this, we want to use the law of exponents. So we're going to say this becomes e to the 2x times e to the y. And now I can move everything with a y over to the left side, everything with an x over to the right side. So we're going to get dy over e to the y equals e to the 2x dx. And now we'll integrate both sides. So I'll have the integral of 1 over e to the y dy is going to equal the integral of e to the 2x dx. We could write this as the integral of e to the negative y dy is going to equal e to the integral of e to the 2x dx. So now we have to be very careful. The integral, the antiderivative of e to some power is still going to be e to that power. But imagine if we had to take the derivative, we would get e to the negative y times negative 1. So in this case, we need the reciprocal of that, which is also just negative 1. So we just need a negative sign in front of it. And we'll still say plus c1. Now over here, pretty much the same process. It's going to be e to the 2x, but then we need to multiply by the reciprocal of that coefficient of the exponent. And then we get plus a c2. So now we'll say negative e to the negative y is going to equal 1/2 e to the 2x, and we'll just call it 1 overall constant here. Even if our constants change, we could still leave it this way. Actually, it is going to change one more time, so let's go ahead and call it c sub 3. Because now I want to divide everything by negative 1. So we get e to the negative y is going to equal negative 1/2 e to the 2x. And then I believe now we should be okay just to call this an overall constant. All right, so now again, this is our implicit solution because we're not completely solved for y. But what we could do now, take the natural log of both sides. Now over here, we want this expression to be positive, so we're still going to keep it in absolute values. So now we'll get just negative y is going to equal the natural log of the absolute value of negative 1/2 e to the 2x plus c, or you could write this as c minus 1/2 e to the 2x. And then we'll divide by -1. So now y is just going to equal the opposite of the natural log of -1/2 e to the 2x plus c. And this is our explicit solution. All right, so as far as yesterday's or Tuesday's homework problems, I gave you 33, 34, 35, and 37. Here's the answer to 34. I will have the work posted for these, explanations for these posted as a separate PDF. So let me know if you have any questions. All right, so now you have the spring break AP practice packet that's posted. Make sure you work on that. I will have the video solutions posted as well. If not by the end of the day Thursday, then possibly early Friday morning. But please make sure you read over the directions. You don't have to sit there and do the whole thing in one day. Do it by parts. But more importantly, check your work. There might be some questions on there we haven't yet gone over, but that's okay. Still watch for the explanations in the video. So now off of pages 322 to 323, you have these 5 problems to do, but only A and B for 45, and then a few more AP practice problems in addition to the spring break AP practice packet. So have a lovely break, guys. Let me know if you have any questions.